Hey everyone, we are Team 6 and our project is Pinball Machine. Welcome to our video presentation. I'm Bhargav AK and my teammates are Srivatsa, Pranav and Chetan Reddy. We are under the guidance of Mr. Raghuraj Adi sir as our mentor. Our problem definition is fully based on the need statement of a game machine. The need statement is a new shopping mall which has opened in Hubli is interested to have an innovative interactive robotic game in their game center. So we decided to design a semi-automatic pinball machine which has all the features of a traditional pinball machine, and it should contain minimum of 3 balls and plus 2 extra. It should work on both battery and external power supply, and the project should be built in budget which is of 3000, and it should work for 3 hours continuously. The game shouldn't be too complex and should be fun to play. So here is our functional tree and functional clustering. Functional tree. For our pinball machine, we have considered 4 functions: turning the game on and off, launching the ball, hitting the ball and counting the score. Turning the game on and off is our main function, and it is done by controlling the buttons. Control buttons are sub-function. Launching the ball is our main function, and it is done by storing the ball and holding the ball in the launch area. Hitting the ball is our one of the main function, and it is done by moving the pedals or the flippers and by controlling them. Counting the score. When the ball passes from a certain point or area or where our sensors are located, the score gets incremented. So in this way we count the score. Functional clustering. As you can see over here, we have made separate clusters for all the functions. We have identified our subsystems as launching the ball, hitting the ball, sensing the ball and incrementing the score. As you can see in these animations, launching the ball is done like this and hitting the ball is done with the help of pedals, and sensing the ball is done with the help of IR sensors, and score is incremented when the ball passes through an IR sensor. Conceptual design. We have created 4 designs for our project. In concept design number 1, the pinball machine is controlled by an Android app in your phone. There are buttons to start the game and control the speed, and there are buttons to control the flippers to hit the ball. In this design we are using DC motors for launching the ball, and we are using servo motors as flippers. Conceptual design 2. In this design, the flippers work on the principle of the reverse piston method. In this system, the rotational motion of the motor is converted into the linear motion. The launching of the ball is made by the spring thread system. The player can control the launch speed of the ball. As the score increases and reaches a stage, the difficulty starts to increase. As the slope of the play area increases by increasing the elevation of the top region. In this system, we use piezo sensors for counting and increasing the score. The controller is present at the lower end, and the controller also works with 2 IR sensors, each one controlling a flipper. The controller also contains a display in the middle. So this is our conceptual design number 3. The pinball machine is made into a shape of a guitar. This machine has the display at the top and the balls are stored at the top. As the game starts, the ball is dropped and the game ends if the ball falls down in the storage area or restricted areas. And after certain games, the balls are to be taken out and has to be refilled from the top. Conceptual design number 4. This pinball machine is just like a classic pinball machine. To increase the difficulty, there are extra balls stored in the specific play area which gets released after the player gains certain score. In this system, the launching of the ball is done by a conveyor belt, hence there is a restriction to the player that he cannot set the launching speed of the ball. We have selected the conceptual design number 1 as our final concept design. Virtual implementation. 3D model of the entire system. Here are the 3D models of the parts used in the project. This is the DC motor used for launching the ball and as the bumpers. This is the outer casing of the box on which the play area of the pinball machine is supported. These are the flippers or pedals used for hitting the ball, which are controlled by the player. These are L clamps used for supporting and connecting the system. This is a screw used on the DC motor for support. This is a nylon rod used on top of the DC motors for support of bumpers. These are sensors used for sensing the ball. And this is the bouncer. When the ball comes and hits the bouncer, the ball will be bounced back. This is the final 3D model of the entire system, and this is the play area of our pinball machine.
This is the circuit diagram of our entire system. These are the IR sensors which are used for sensing the ball. These are servo motors which are used as the flippers so that ball is controlled. And these 4 are the DC motors. One of the motor is for launching the ball, and another 3 motors are for used as the bumpers to control the direction of the ball. And this is a Bluetooth module which is used to send the data from Android app to the Arduino. Bill of materials required for the entire system. We are using microcontroller keys Arduino Mega. 1 quantity is required. DC geared motors 5, servo motors 2, body of the machine which is the material made up of HDF sheets. Quantity code is 2, fabrication is jigsaw, casing is acrylic sheets. Quantity code is 1, they are using laser cutting. Flippers same acrylic sheets. Quantity code is 3, they are using laser cuttings. Large rubber bands, quantity code is 15. IR sensor quantity code is 8, balls quantity code is 3, L-clamps quantity code is 20, screws quantity code is 40, super glue tube and nylon rod 2. These are bill of material for the pinball machine. This is a simulating model of our entire system, and this is the DC motor code which is used to run the DC motor so that the ball is got launched. And this is the code for IR sensor which is used to increment the score. And this is the IR sensor which is used to stop the game, and this is the same IR sensor which is used to stop the bumpers so that the ball is not, because ball will be not there. And this is the IR sensor which is used to start the DC motor, and this is the servo motors code. Here it is a Bluetooth module will send the information. 2 information, one is L and one is R. L is used for controlling the left flipper from 0 degrees to 60 degrees, and the R is used to control the right flipper from 180 degrees to 120 degrees.
Motor sizing and battery sizing of the entire system. Motor sizing. We are considering a ball of weight 6 grams and the diameter of the ball as 5 cm. By the calculations made, the minimum torque required for the DC motor used for launching is 0.015 kg/cm. So we are considering a motor of maximum torque 0.25 kg/cm, which has a maximum RPM of 500. DC motor for bumpers. We are considering the same motor of torque 0.25 kg/cm and which has a maximum RPM of 500. servo motors used for flippers. We are taking the servo motors which produce torque 1.5 kg/cm and which has 130 rpm. Battery sizing. For launching the ball we need one DC motor, and for flippers we need two servo motors, and for bumpers we need three DC motors. And we are taking 20 LEDs and 10 IR sensors. So the total currents required is 2420 mAh, so we are taking a battery of 3000 mAh. Function specifications of the entire system. Function. Launching the ball. When the game starts, the ball should be launched in the launch area. Hitting the ball. The flippers should hit the ball when the input is given. The flippers are controlled by an app through Bluetooth module. Sensing the ball. The ball is sensed when it passes through a IR sensor. Incrementation of the score. When the ball is sensed by the sensor, score is incremented and displayed. Modeling and simulation.
Hello, this is our simulation model for our pinball project, and now I will say you how our project will work. Now first, this is the code for the DC motor which is used to launch the ball. When ball is sensed by the IR sensor, then DC motor will start rotating and it will send the ball to the main board, and it will rotate for the 15 seconds. Afterwards it will stop automatically. And now this is the code for the score incrementation. When ball sensed by these other sensors which are in the main board, and it will sense the ball, and the score will be getting incremented and displayed on the LED screen. When this sensor value is 0, the game is start, and here the score is getting increased. And if this sensor value is 1, if ball sensed by the sensor, then the game got over. The game is to stop the ball which should not be get sensed by this sensor, and which is controlled by these servo motors which are used as the flippers in this game. And these flippers, there will be two flippers, one is right flipper and is left flipper. Suppose if left flipper is on, then the servo motor rotate from 0 to 60 degrees. Suppose the right flipper is on, then the right flipper will the servo motor will rotate from 180 degrees to 120 degrees. And if the ball got discontrolled, and if it falls near this sensor, and if this sensor reads the ball, then the game got over.
And thank you for watching our video documentation.